welcome to Students Dominate Math. My name is Mr. Hendricks, and I'm going to be your host for the next half an hour. This is a live call-in interactive show brought to you through the facilities of CAN TV. The number that you can call in to receive math assistance, if you need some tutoring in your math work, you can call the number 312-738-1060. And I will do the best that I can to assist you on the math questions that you have. I told a few of the students at Providence St. Mel School about this opportunity that we had this evening. And I'm hopeful that they're watching, and I'm hopeful that we get at least one call tonight. We can assist in the areas of algebra, trigonometry, calculus, and statistics. We can help with some statistics as well. I'll do the best that I can. But the show runs best if you call in 312-738-1060, and we will help you. The way the show works is you call in. But if you don't call in, I typically have work that I've brought that we can practice. And we'll study that until we get some callers. Before we get started, I wanted to make an announcement. Providence St. Mel is having an open house. I'll try to mention it later this evening. But the open house is March 30th. You come and you talk to administrators, you talk to staff, you talk to students about their experience at Providence St. Mel, you talk to teachers about the curriculum, you talk to administrators as far as what the vision is of the school, the different financial aid opportunities to attend a school like Providence St. Mel, and hopefully it would be a good fit, and it would be a school that you consider for your student, for your child. I'll try to mention that a little bit later on in the show. But this is a math tutoring show, and what we're going to do is we're going to practice a couple problems. Hopefully we get some people to call in. Again, the number is area code 312. The phone number here, I'm going to write it down so you can see it. 312-738-1060. All right, let's just get started. All right, so the first problem that we're going to attempt is a problem where hopefully you can see that. Might have to pull it out a little bit. Oh, that's a little bit too much. All right, so you call in the number 312-738-1060 if you have any questions. All right. First problem we're going to do is we have this function, let this function 4x cubed minus 3x minus 1, and we say, it says an equation of the line tangent to this graph at x equal 2 is which one of these equations? Okay, and the thing I like to share with my students is anytime you have to write an equation, this is, oh, by the way, this is an AP Calculus problem that comes from the workbook that our students purchase. And we practice, there are a lot of problems in this booklet. We practice these problems in preparation for the advanced placement AP Calculus test. So that's where this problem is coming from. All right, so the thing I tell my students is, I tell them that to write an equation of any line, you need a slope and a point. And if you look at this problem, they have f sub x is 4x cubed minus 3x minus 1. And then they say they want the equation of the tangent line at x is 2. To write the equation of any line, you need the slope, m, and you need a coordinate. You need a coordinate. You need a point, rather. You need a point. You need a point, and with a point and a slope, you can write the equation of any line. Hopefully you see here that if you just substituted in 2 into this equation, you could get f sub 2 is 4 times 2 cubed minus 3 times 2 minus 1. That's 8 times 4, which is 32, minus 6 minus 1. You end up with, that's going to be 26 minus 1, which is 25. You end up with f sub 2 is equal to 25. That's your point. That's your point. 2, 25. That's the first thing that you would need to write the equation of a line. You need a point. The second thing that you would need, to write an equation of a line is the slope. And it turns out that that slope can come from the derivative. You have the equation f sub x, 4x cubed minus 3x minus 1. If you took the derivative, of 4x cubed minus 3x minus 1, you drop the 3 down, you multiply it to the 4, you get 12x. You reduce the exponent here on the 3, you get 2. And then you take the derivative the same way with the 3x. That's an assumed exponent 1. You multiply that 1 to the 3, you get 3x to the 0. You reduce the exponent 1. That's the same thing as 3. So the derivative here is 12x squared minus 3. Okay, that's the derivative. And it turns out that the derivative equation gives you the slope everywhere on the original function. If you need the slope anywhere on this original function, the derivative equation will supply it for you. For this particular problem, it turns out that we want the slope at x is 2. So we apply the derivative, use the derivative equation, evaluate it at 2. We get 12 times 2 squared minus 3. And that gives you, if you follow the order of operations, that gives you 12 times 4 minus 3, or 48 minus 3, or 45. 45. So it turns out that the slope at 2 is 45. F prime sub 2 is 45. So now you have the slope. You have the slope is 45, and then you have a point 225. You can apply a little algebra. Y is equal to mx plus b. Substituting in the point 225 and the slope of 45. Okay, and you get plus b. You end up with 25 is 90 plus b. You subtract the 90 on both sides, and you end up with, that's going to be 65, I believe. Your y-intercept is 65, and now your equation would be y is equal to 45x plus 65. That would be your answer. So you would choose B. All right, B is your answer for that particular problem. So our students at Providence St. Mel have their exams this week, starting tomorrow. So I should have done a better job of informing them that we have a show where we really welcome their questions. We really welcome their questions. And we invite them to call in. I'll do a better job next time. That way we can get more interaction between you, the viewer, and me, the host. I want you to call in. You might be from Providence St. Mel, or maybe you're not from Providence St. Mel, but you just happen to discover this show. Come on now, you call in. I think I can help you. You call in the number. You might be a college student. If you have a math question, you call that number on the screen, 312-738-1060. And for the next 5-10 minutes or so, I'll be your math tutor. You got a personal private math tutor right here. I'd love to help, but you got to sometimes help yourself. You call in 312-738-1060. All right. And if you don't call in, what we're going to do is we have another problem. Oh, by the way, I mentioned it earlier, but we have at Providence St. Mel, we have a open house coming up, March 30th. You come to Providence St. Mel if you want to consider Providence St. Mel as a school for your child. You call in, and we can tell you a little bit about it. But you come in on March 30th at Providence St. Mel. The address there is 119 Central Park. 119 Central Park. We do have a caller. Amen. We got a caller. Caller, good evening. How can we help you? Welcome to Dominate Math.
Hi, Mr. Hendricks. Can we go over graphing, sine, and cosine?
Okay, you wanna go over graphing the sine and cosine functions? Yeah, we got cut off. But I think the caller said that they wanted to practice graphing sine and cosine function. All right, so let's talk about that a little bit. The way we're going to begin, and by the way, thank you for calling in, caller. You call in again. All right, so the first thing that I'll say, let's ignore this for right now. First thing that I'll say is it's going to be important. It's going to be important to have an understanding of the parent curve. All right, so I'm going to first draw the parent curve. All right, so the parent curve for the sine function would look something like this. That's pi, that's 2 pi. All right, so this is the parent curve for the sine function. All right, so you got to know that. And you also, to handle the problems that I'm going to give you tomorrow, you also got to know what the parent curve for the cosine function. All right, so that's 1, that's -1. All right, so the parent curve for the cosine function, okay, would look something like this. It starts up top here, it looks something like that. Okay, so that's the parent curve for the cosine function. Now everything that I give you is going to look something like one of these, okay? So let's do one example of each. All right? Okay, we can call in. You can have another caller. While I'm doing this problem, somebody else can call in the number 312-738-1060. All right, so let's say we have a problem where I ask the student to graph y is equal to 2 sine x, sorry, 2 sine of 4x, okay? So what that would look like is, a graph where this 2 tells you how high the graph, how low the graph should travel. All right, so it's called an amplitude. The amplitude of this graph would be 2. This term here within our expression is called the frequency, which means how frequently will you see this parent curve between 0 and 2 pi. Well, the frequency for this is 4. So what that means is, again, you're going to see the height of the curve extend to 2 and negative 2 throughout the entire graph, okay? And then you're going to see 4 sine curves between here and here. So the first one would be here, first one would be there. That's the first sine graph. Looks sort of like that, but there are four of these between here and here. All right, there are 4 of them. Okay, so another one would fit between pi over 2 and pi. That's the next one. That's the second one. You got to fit 4 of them. The third one would fit here, and then the last one would fit between there, about something like that. So that is 2 sine of 4x. The period would be, the way you calculate period would be 2 pi over whatever the frequency is. The frequency, as I said earlier, was 4, so that simplified would be pi over 2. So the period is pi over 2. With the graph, I might ask you, what's the amplitude? What's the period? What's the frequency? All right, so what that means is every single sine graph would require pi over 2 radians. So that's pi over 2 radians. That's another pi from here to here. That's another pi over 2 radians. That's another pi over 2 radians necessary for the full sine curve. All right? All right, so let's, that's a graph of that one. Let's graph one more. That's what would y is equal to the cosine of 2x. What would that look like? It's going to look something like that. It's going to look something like that. So let's graph that real quick. Let's graph that real quick. I want you to call in 312-738-1060 while I'm working on this problem. So when I'm done with this one, we'll have another caller right after that. It might even be the same young man that called in earlier. All right, we want to help as many people as we can tonight. All right, so now let's graph this. The amplitude here is 1 because there's no number there. Let's put a pi. Let's put a 2 pi there. All right, so here the amplitude is 1. The amplitude is 1. Let's put a 1 here, a negative 1 here. The frequency here is that number. That's the number of cosine curves that we need to fit between 0 and 2 pi. So I'm going to need to fit a cosine curve in here, and I'm going to need to fit another cosine curve between here and here so that I can fit 2 of them between 0 and 2 pi. So let's do that. Go down something like this. That's a full cosine curve. That's a full cosine curve between here and here. Now I got to fit another cosine curve between here and here. All right, so something like this. That's what we're looking for. All right, so the amplitude would be 1. Amplitude is always positive. The frequency is 2. How frequently do you see the cosine curve between 0 and 2 pi? Okay, the period is 2 pi over whatever the frequency was, so that would be pi, which means the number of degrees, in this case radians, necessary for a full cosine curve. From here to here, that's pi, and from here to here, that's another pi radians. And then the range, which we didn't talk about over here, is the y values that this curve sees. The y values here would be from -1, oh boy, having some challenges with my pencil, from -1 to 1. Maybe somebody could call in and tell me what the range would be here. Maybe somebody could call in. The number 312-738-1060. You call in and tell me what the range is there. Okay, I don't think we got any callers calling in. The range here would be the y values from -2 to 2. All right, so I hope that the caller that called in is satisfied. We did 2 problems where you have to understand how to graph a trigonometric equation. We have time for one more caller. Hopefully you call in. If you got time for one more caller, but you got to call in right now so that I can help you. Since we don't have any calls, let's have, maybe we got time for one more calculus problem. Okay, we got time for one more calculus problem. All right, let's take a look. All right, let's take a look. This problem here, it's an antiderivative. Okay, it's an antiderivative. And they want you to find the antiderivative of arctan x over 1 plus x squared dx, okay? And the thing that I tell my students is I ask them to, before they begin the problem, go through a thought process of first trying to turn this into a polynomial. If they can turn this into a polynomial, they can apply the easiest technique of evaluating an antiderivative, which is the power rule. If they cannot turn this into a polynomial where they can apply the power rule, I ask them to use U-Substitution. And the thing that I would do here is substitute, make U arctangent of x. Make U arctangent of x because the derivative of U is nested within the problem. It turns out that the derivative of arctangent of U is 1 over x squared plus 1 squared. All right, x squared plus 1 squared dx. That's what the derivative of the arctangent of x is. And oh, we have a caller. Caller, what's your question real quick? We only got a minute.
Yes, can we go over complex fractions?
Caller, I'm sorry, we'll go through it. Come to Providence St. Mel. Okay, you're a Providence St. Mel student. Come first thing in the morning, okay? And we'll go over that before you take your test. We don't have time to do that right now, okay?
All right. Thanks.
All right, first thing tomorrow morning, meet me in the auditorium at 7:30. God bless you.
Okay.
All right, let's finish this out. So we have the antiderivative of u du. This is the same thing as the original problem. Okay, it's the same problem. All right. So we're really running short on time. The antiderivative of this is 1/2 u squared plus c. All right, and then you would put the u back. You put the u back, you'd end up with 1/2. Sorry about that. 1/2 arctangent of x, and then that would be squared plus c. All right, and then the correct answer would be A. All right, so sorry we ran short on time. Sorry we couldn't respond to that student's question, but he's going to get his question answered tomorrow morning. God bless you. Students out there, never quit. You put forth your best effort. Ask questions when you have them. Don't be afraid to ask questions. Never quit. And remember, all students can and will dominate. God bless you. Have a good evening.